All right, guys. For some reason, my little section on naming acids didn't make it into the Chapter 4 lecture. So here's going to be a little lesson in naming acids. Now, let's talk about what acids are. Acids are covalent compounds that, when dissolved in water, react with water to produce hydronium ion. Now, I'm going to write you out a reaction. HCl, AQ stands for aqueous, plus water liquid goes to H3O plus aqueous and chloride ion. Okay? This is called an acid ionization reaction because I take a covalent molecule, HCl, and it reacts with water to produce ions. Ionization, taking something that didn't have ions and making ions out of it. Okay, so that's the definition of an acid. Now, we're going to recognize acids because acids have hydrogen listed first in their formula. So HF, HNO3, HBr, H2SO4. These are all acids. Okay? Acids. If the hydrogen doesn't appear first in the name of the compound, we don't have an acid. Let's give ourselves a little working room here. So if I have NH3 or CH4 or pH3, okay, hydrogen's appearing second in the name. These are not acids. So you're going to recognize acids because acids are going to appear first in the formula. Okay? Now, when we're naming acids, the name is going to be based on the anion that's released when the acid is ionized. So if I just write out some acids, HCl, HNO3, HClO4. Okay, if you cover up the hydrogen and you look at what's left, okay, you see the anion. There's the chloride ion, the nitrate ion, and the perchlorate ion. Okay, so the names of those three acids are going to be based on the names of those anions. All right, now, when we're naming acids can be named two ways. One name is based on the treating the acid as if it were a salt, and you do that when it's in its pure form. So if I have HCl, G for gas, that would be pure HCl. Its name is going to be hydrogen chloride. Okay, if I have HNO3 gas, this would be hydrogen nitrate. Okay, if I have HClO4, it would be hydrogen perchlorate. If it was a gas. So if you have the pure acid, it's going to be named as if it were a salt. Okay? Now, most of the time when we get acids, the acids are dissolved in water. So the acids not only have a name when they're pure, but they have a dissolved name. Now, I'm going to write out some rules here, and then we're going to practice. So, if the anion name ends in IDE, then we're going to put hydro and then the base name of the anion and then ic acid. If the anion name ends in ate, we're just going to go base name of anion and then ic and then the word acid. If it has an ite ending, we go base name anion us acid. So you change the ending to ic or us. And if the anion ended in ide, you slap hydro on before. So ide, ate, and ite. So we're going to look at some examples here. Okay? So let's look at 8Cl, 8ClO, HClO2. Let me write this up higher. 8Cl, 8ClO, 8ClO2, 8ClO3, and I'll put it up here, 8ClO4. No, write them up from top to bottom, and then we'll look at them. Okay, here's a family of acids. Okay, so 8Cl, hydrogen chloride, if it was pure, so we call it hydrochloric acid. 8ClO, that's the perchloride ion. No, yeah, the hypochlorite ion. So this would be hydrogen hypochlorite. So this would be hypochlorous acid. Okay, base name of the anion with the ending changed to us acid. This is hydrogen chlorite. So this would be chlorous acid. This is the chlorate ion, ClO3. So this is hydrogen chlorate. So that's chloric acid. And last but not least is hydrogen perchlorate. So this is perchloric acid. Okay? So if it's pure, it's given its name hydrogen, whatever the anion it releases in. If it's dissolved, you're going to use ic and us as endings instead of ide, and ate. And then you've got to use the name of the anion. So let's look at some examples here, just a few, and then you can practice. So if I have 8CN, hydrogen cyanide, if it's pure, would be called hydrocyanic acid if it was dissolved in water. Okay? If we have HNO3, that would be hydrogen nitrate if it was pure, and nitric acid if it was dissolved in water. If I have H2SO4, pure, it would be hydrogen sulfate. Dissolved in water, it would be sulfuric acid. Okay? So, just like the other naming, it's just going to take practice. Keep practicing. All right, guys. Just in case also I left it out for some reason, let me remind you about metallic bonding. Okay? Let's look at this. Now, we talk about metallic bonding here. Okay? Oh well. Talk about metallic bonding. It's pooling of valence electrons. Atoms share all of their valence electrons between all the atoms in the solid or liquid phase. This bonding then goes on between groups of metal atoms, okay, in the solid or the liquid phase. We can put them together in any ratio, which leads to the formation of those metal alloys. And the properties are that metals have lower melting points, but very high boiling points, because to boil, each atom has to gather up its electrons to leave the party. And they'll conduct in the solid phase and they'll conduct in the liquid phase, and they're workable. And it's all based on the fact that they share their electrons. All right, guys, that should be the missing part out of chapter 4.